You know, the biggest problem for self-driving cars? It's us. We're humans. We're unpredictable. So how in the world do you teach a machine to anticipate our every move? Well, today, we're diving into a really cool breakthrough from Waymo that might just be the answer. Okay, so put yourself in the driver's seat or in the main processing unit of a self-driving car. You look out, and this is your view. A cyclist, a red light. Simple enough, right? For us, yeah. But for a computer, this is an absolute minefield of possibilities. So what's going to happen? Is the cyclist going to wait patiently for the green? Or are they about to just dart across the street against the red? We make that judgment call in a heartbeat. But in AI, it has to learn this from scratch. And the stakes are impossibly high. It has to be right every single time. And that, right there, is what engineers call the prediction problem. See, for a car to be truly safe, it can't just be reacting to what's happening right now. It has to see into the future, even if it's just a few seconds ahead. The research paper lays it out pretty clearly. The car has to, and I quote, model the behavior of every nearby agent. It's not enough to just spot a pedestrian and say, hey, there's a person. The AI has to predict where they're going, using all the same subtle clues we do. So for years, developers have been kind of stuck, between a rock and a hard place. They had two main ways to tackle this prediction thing, and neither one was perfect. And this wasn't just some minor bug. It was a huge, fundamental roadblock for the whole industry. All right, so this lays out the big trade-off they faced. On one hand, you've got the symbolic approach. It's fast, it's efficient, but it sees the world in super simple terms, like everything is just a box or a line. The problem? It misses all the nuance, right? Like a driver's side-eye glance or a patch of wet pavement. Then you've got the end-to-end method. This one sees everything, all the raw sensor data, but it's a computational monster, and it's a total black box. You have no idea why it made a decision. So the choice was simple but kind of blind, or super powerful but completely mysterious. But what if you didn't have to choose? Waymo's team basically decided, you know what? Let's stop trying to pick one. They asked a much better question. What if we could have the best of both worlds? And that's where this new system comes in. They call it MOST, which is short for Multimodality Scene Tokenization. It's a really clever hybrid approach. Think of it like this. It creates a whole new language for the AI to understand the road, and it does that by grabbing the best parts of those two older methods. I love this quote from the researchers because it just sums it up perfectly. They say they're not trying to choose between the two. Instead, they're combining the simple stuff, the symbolic representations, with these new learned tokens that soak up all the rich, messy details of the real world. Okay, so how does this thing actually work? Well, the best way I can explain it is this. MOST doesn't just teach the car to see the world, it teaches it to read it. It all starts with the car's senses. You've got two main inputs. First, the cameras, basically what our eyes would see. And second, you've got LiDAR, which is super cool. It shoots out lasers to build this incredibly precise 3D map of everything. MOS's whole job is to take these two very different views and fuse them together. So the very first step is to take all that chaotic information and bring some order to it. I mean, instead of trying to process this giant, messy soup of pixels and laser points, MOST does something really smart. It breaks the scene down into understandable chunks. And here's how it sorts everything. It's basically three buckets. First, you have agents. These are the movers and shakers: cars, cyclists, people. Then you have ground. That's the road itself, the lane markings, the curbs. And finally, there's the open set bucket. This one's the catch-all for literally everything else. And that part is so important because it's how the car deals with the unexpected, a stray traffic cone or some junk in the road. Okay, so once everything is sorted into those buckets, MOST starts creating what it calls tokens. Let's take one element, like a pedestrian. MOST will pull all the important details about that person from both the camera and the LiDAR. Then it bundles all of that info into one tiny, compact digital token. It's like a super word, a single word that describes that person perfectly for the AI. And here's where the magic really happens. All of these rich, descriptive tokens get fed into a really powerful kind of AI, a transformer model. Now, you've heard of these. It's the same tech behind things like ChatGPT. And just like ChatGPT understands a sentence by looking at how all the words relate to each other, this transformer understands the road by seeing how all these scene tokens relate to each other.
It's a way deeper, more contextual way of understanding what's going on.
Okay, so that's the theory, right? It sounds great on paper, but does it actually, work? Well, the results are in, and they show this new hybrid approach leads to way better and way safer predictions. The headline number you need to know is this: 10.3%. That's a 10.3% improvement in prediction accuracy over the best model they had before. Now, in the world of AI, getting a jump that big on a key metric is a huge deal. It's not a small tweak, it's a major leap forward.
And check this out. This shows you what that 10% actually looks like. On the right, you see what the old model predicted. It thought the car making a U-turn might actually drive right into the wall. A little worrying, right? But on the left, with MOST, it gets it. It understands the shape of the road, it sees the curb, and it correctly predicts a much tighter, more realistic turn that stays right where it's supposed to. This next one is even cooler, I think. So the car is driving into a plaza that it doesn't have on its map. The old model is totally lost. It's like, no road here. I guess I'll just go straight. But most actually reads the visual cues. It sees the arrow painted on the pavement with its cameras and correctly predicts the turn. That's huge. It means most can reason about the world even when it doesn't have all the information.
Okay, but this is where it gets really impressive. The researchers decided to stress test most. They started taking away its data to see what would happen. Now, these numbers measure its performance. Higher is better. Look at this. Even when they take away a whopping 50% of the perception data, meaning half the stuff around it is invisible, most performance is still almost as good as the old model was with perfect data. That is an insane level of toughness.
So let's zoom out. What's the big picture here? What does all this mean? Well, this isn't just a big deal for Waymo. This kind of breakthrough could have ripple effects across the entire future of AI. So when you boil it all down, MOST is a massive step forward for making self-driving cars safer and smarter, especially for handling those bizarre one-in-a-million situations that are impossible to plan for. But think bigger than just cars for a second. This whole idea of tokenizing the real world, of turning messy, chaotic sensor data into a clean, understandable language for an AI, that could be a game changer for everything from robotics to medicine. And that brings us to one last big question to think about. We've just watched an AI learn to read the incredibly complex language of the road. If it can get that good at understanding our world, what other complex environments could it navigate next? A chaotic factory floor? Inside a surgical operating room? Maybe even the surface of another planet? It's a pretty wild look at where this is all heading.